In this video, we'll be going over our function operations. So for this first part that we have our notation, and a lot of this seems very straightforward with our notation. So let's go ahead and jump on into it. Notice this first part, you have addition, and so the equivalent operation here would be f at x plus g at x. And for our next one, we would have f at x minus g at x. And then also for our multiplication, just what you would think, it would be f at x, that value times g at x. And also for our division, so that's going to be f at x divided by g at x. So when we talk about the domain though, notice that with our new function is the intersection of the combined functions. So the domain is a little bit more restricted with the quotient function, and so we need to make sure that denominator is not equal to 0. Right, so let's check out some of these problems. Notice that the first one we have our addition, and so with that addition problem we are going just to add our two functions together just like we would back in Algebra 1. So this implies that we have the function f at x and we're going to add the function g at x. So when we put those together, notice that we are going to end up with x squared plus x, and then I'm going to have plus, and then our other function we've got 3x minus 1. Now back in the Algebra 1 days, y'all were told if nothing's in front of the parentheses that y'all can just drop it. And then we're going to go through and combine what we can here. So let's see, we can put together those middle terms, and so we're going to get x squared plus 4x and then minus 1. And now it wants us to also state the domain. This is a polynomial, so the domain is going to be all real numbers. Okay, for our next problem, we are subtracting, so do keep in mind this means that you're going to have f at x minus g at x. And so when we're subtracting our first function, we have x squared plus x, and then minus, and I'm going to make sure I put that second function inside the parentheses because I will need to distribute that negative. So I have x squared plus x minus 3x plus 1, and now again combining those terms, it looks like we have x squared minus 2x plus 1, and again this domain would be all real numbers. Okay, moving on to our multiplication. Again, this is going to imply f at x times g at x. And so when we do that, we're going to have x squared plus x times 3x minus 1. And when we multiply this out, keep in mind this is kind of like doing our FOIL. We're going to have 3x cubed minus x squared. And then on the inside here, we're going to have plus 3x squared minus x. And combining these terms, we have 3x cubed minus 2x squared minus x. And the domain, again, is all real numbers. Now, on part D, it looks like we might have a little bit of a restricted domain here. We have f at x over g at x. And so notice for this one, we will have x squared plus x, and that's going to be over 3x minus 1. Now this is where our domain is going to be restricted because we can't have that denominator equal to 0. So I need to find what number is going to make that 0. And notice we end up with 1/3. So here our domain will be all real numbers except, and then here x cannot be equal to 1/3. Alright, so for our next problems, more of the same types of things here. We're going to have our function f at x plus our function g of x, so we're going to have x squared plus 9 plus the square root of x. And you can't combine those like terms, so that's all you can do with that. However, when we're doing the square root, x has to stay greater than or equal to 0. So here when we talk about the domain, we're going to talk about from 0 to infinity, and that is included. The 0 is included. Right, so looking at part B, we're subtracting these two functions. So that means we're going to have x squared minus 9 minus the square root of x. And again, very similar, our domain is going to go from 0 to positive infinity. On the next part, we're going to be multiplying these. So I'm going to have x squared plus 9 times the square root of x. And we can do our distributive property here. And so when I multiply that, I have x squared times the square root of x, and then plus 9 times the square root of x. And again, this domain here, same situation, x has to stay greater than or equal to 0. So there's our domain. Over on the next problem, notice here this is dividing, so we might have to do some rationalizing here. So again, starting out, f of x is our numerator, and the denominator is the square root of x, so we definitely need to do some rationalizing here. Multiply top and bottom by root x, and when we do that, as far as multiplying this out, I'm perfectly okay with your leaving this, the square root of x times x squared plus 9, and then in the denominator, that is going to multiply and just be x. So here we've got a couple of things about our domain. We definitely need to stay greater than or equal to 0, but for this portion, can't be 0. So our domain here is not going to include 0, and then it is going to tend toward infinity. Okay, for our next example, again we have our function g plus f. So our function g, let's keep in mind there's that x squared minus 4x. And then we're going to have, get that going, my pen didn't want to write, x squared minus 4x. And then I'm going to add to that our f of x function, which is 2x cubed. And here there's nothing more we can do with that. This is a polynomial, so my domain is all real numbers. Our next problem, we need to subtract this, and now the order is going to be important. It is f of x minus g of x, so f of x is 2x cubed minus our g of x is going to be x squared minus 4x. Again, we can distribute that negative, and it doesn't look like we're going to have any terms to combine. And their domain, again, for this polynomial will be all real numbers. Part C, we're going to multiply these two. So when multiplying them, we've got 2x cubed. And I'm going to multiply to that x squared minus 4x. I will do our distributive property here. So that's going to be 2x to the 3 plus 2. So that's going to be to the 5th. And then I'm going to have minus 8x to the 4th. And again, the domain here, this is a polynomial, so it is all real numbers. Part D, we're going to have a function here. We are dividing, so f of x is going to be our numerator, so that's going to be 2x cubed over the denominator is going to be x squared minus 4. X. Now we can reduce this down. Notice you have a common factor in the denominator, so let's go ahead and reduce that down. I'm going to factor out an x, and so that's going to leave me with x minus 4. And now from here we should be able to cancel these two, and so that's going to leave me with an x squared in the numerator. So our final answer here is going to be 2x squared over x minus 4. Now our domain is it would be great if it was all real numbers, but it's not. We have a rational function here, so I've got to take x minus 4 and set that equal to 0 and solve, and notice that the number 4 is going to make that denominator 0. So here our domain is going to be all real numbers, and then we're going to have except x cannot be equal to 4. In example 4, we have f plus g of x. So we have two fractions now. So we have 1 over x plus 2 over x plus 2. And we know a fast way to add those fractions. In the denominator, we're going to multiply these, and really we're just going to write them side by side for the time being. And then in the numerator, you're going to cross multiply. So I'm going to multiply 1 times x plus 2, and that's going to be x plus 2. We take the sign between it, so plus, and then I'll multiply the other direction, x times 2, so that's going to give me 2x. So to simplify the numerator, I'm going to have 3x plus 2 over x times x plus 2. And that won't be able to be reduced any. Okay, so for part B, notice you've got g of x minus f of x. So again, we've got two fractions. G of x is first, so we're going to write 2 over x plus 2 minus 1 over x. And we're going to do the same steps again. When we add those, we will need to multiply the denominators. And then to get the numerator, we'll multiply x and 2. So that's going to give me 2x. And then minus. And then I'm going to multiply x plus 2 times 1. That's going to give me x plus 2. And I'm going to keep that in parentheses so I don't mess up a sign. So in the numerator, I'm going to have 2x minus x. So that's 1x. And then minus 2. And then that's all over x times x plus 2. Moving to the next part, we have multiplication here. And notice it is g of x times f of x. So I'm going to have 2 over x plus 2 times f at x, which is 1 over x. And when we multiply fractions, we can multiply across the top and then across the bottom. And we don't have to distribute any of this out. We're just going to write it side by side. Okay, and then in part D, now part D here, we need to go ahead and divide these. So let's divide them. So f of x over g of x. F of x is 1 over x, and I'm going to write it like this, divided by, and then we've got g of x, which is going to be 2 over x plus 2. And remember, dividing fractions, you are really multiplying by the reciprocal. And now we multiply across the top and bottom, so we're going to have x plus 2 all over 2x. Now let's go back and talk about the domains for each one of these. So in part A, notice in the denominator we have an x and an x plus 2, and those can't ever be 0. So to figure out where these would be 0, the first place here we would have x to be 0 is at 0, and then this other portion, x plus 2, if we solve that, we're going to get x equals negative 2. So our domain will be all real numbers. So here when you write that domain, it is all real numbers except, and then notice x cannot be 0 or negative 2. Okay, on part B, notice that the denominators are exactly the same. So that would imply that our domain, again, is going to be all reals except, and again, x cannot equal 0 or negative 2. Looking at the next problem, part C, again, same denominator, so therefore you have the same domain. It's going to be all reals except, x cannot be equal to 0 or -2. And now notice on part D, though, that denominator is different. So here we're going to take that denominator, set it equal to 0. So x is 0. And so for this one, the domain is going to be all reals, except when x is 0. Okay, so for example 5, we have g plus f of x. Now these are two radicals and they are not equal to each other, so we really can't do anything with these other than just writing them down and saying the square root of x plus 2 plus the square root of x plus 6. That's about all we can do with that. Now for the domain of this, remember we can't take the square root of a negative number. So I'm going to pick on the one radical that looks like it's going to be the less amount, which would be x plus 2. And we need to keep in mind that that needs to stay greater than or equal to 0. So x has to stay greater than or equal to -2. So that's going to be our domain for this one. The domain would be x is going to be greater than or equal to -2. Okay, f of x minus g of x. Again, all we can do with this is do the square root of x plus 6 minus the square root of x plus 2. And again, for the domain, you're going to pick the smaller of these two, which is x plus 2. So that's the same thing that we did back over here. So it's going to have the same domain. It's going to be x has to stay greater than or equal to -2. Now for part C, we're multiplying these. And again, with the multiplying, then we have to go through and say the square root of x plus 2 times the square root of x plus 6. And with multiplying, you can put these together under the radical. So that is the square root of x plus 2 times x plus 6. And then our domain here, again, you are looking for the smaller of the two. So it is again x plus 2, so that is going to be x is greater than or equal to -2. Okay, and then in part D, you're going to have division here. And so that's going to require us to do a few more steps, I think. We're going to have the square root of x plus 6 over the square root of x plus 2. So we're going to have to rationalize here. Multiply top and bottom by the square root of x plus 2. And so in the numerator, we're going to have the square root, and we can put all of this together. X plus 6 times x plus 2. And then in the denominator, notice that is just going to be multiplied together, and you're going to get x plus 2. And so here, that denominator just ends up being x plus 2. Now for this, that x plus 2, keep in mind that whenever we were looking at the domains, we know up here for that domain, x had to stay greater than or equal to -2. But in this denominator, if I plug in a -2, I'm going to get a 0. And so all that does is tell us that we can't have the or equal to there, because if we plug -2 in the bottom, we will get a 0 there. Okay, on example 6, we need to evaluate the functions. Then we're going to add them together. And what's telling us to do that is that 5 there. So really this becomes f at 5 plus g at 5. So down here we need to find the value for f at 5. So go over to the function f and substitute in a 5, and we're going to have 4 minus 5 squared, and that's going to give us -21. Then we need to go find g at 5. And again, go find function g. That's going to be 2 times 5 plus 8, so that's going to give us 18. And now look, we needed to say f at 5 plus g at 5, Well, f at 5 is negative 21 plus g at 5 is 18. And so when I put those together, I'm going to get negative 3. And that would be our final answer. So in part B, we have f at negative 2 is what that'll end up being, times g at negative 2. So just like we did just a second ago, we need to evaluate f at negative 2. And so when we substitute in f at negative 2, it looks like we're going to get 4 minus a negative 2 all squared. And that's going to be a 4 minus 4, so that's going to give us 0. And then we need to do g at negative 2. And g at negative 2 is going to be 2 times negative 2 plus 8. And so that looks like that's going to be 4. And so f at 2, negative 2 times g at negative 2 is really just going to be 0 times 4, and that's going to give us 0. Okay, another method of combining functions is called the composition function. Given f of x and g of x, the composition function of f of g of x, that is going to look like f of g of x. So what you're doing is substituting one function inside of the other function. And whenever you talk about the domain of a composite function, then it's the domain of g such that g at x is the domain of f. So it's kind of confusing to start with, but it's a lot easier to look at this final expression to come up with that domain. Okay, so starting out, we're going to look at f of g at x. And so with our two functions, it's good for us to remember that that notation means f of g at x. And so what we're going to do is find function f, and function f is x plus 7. And what I'm going to do is everywhere I see an x, I'm going to replace it with this function g of x, that is x squared minus 4. And so that tells me if we combine those two functions, we're substituting g of x into the function f. So where that x is, that's really going to become x squared minus 4. And then I still have the plus 7 that's still left from the function f. And then we can combine these, and I have x squared plus 3. And so that's going to be our composite function here. So again, good for us to remember. And for our domain, notice we ended up with a nice parabola or a polynomial, so that tells me the domain should be all real numbers. Now notice if we reverse the order, we're going to get a completely different answer. So in other words, I'm going to have g of f at x, and so even though we have the same two functions, whenever I plug in f into function g, it's going to look completely different. So let's remind ourselves, g of x is x squared minus 4, and f at x is x plus 7. And so now this time, I'm going to take right here, and I'm going to substitute in x plus 7. And notice the square is going to stay there. So let's look at that composite function. That's going to end up being x squared, but x is going to be that x plus 7. So this is going to be x plus 7 all squared, and then minus 4. And so we do need to multiply this out. It's good for us to remember that x plus 7, that means that you have x plus 7 times x plus 7. And when you pull that out, I'm going to bring this answer down here. When you fold that, you're going to get x squared, and then you're going to have 7x plus 7x, so plus 14x, plus 49, and then you're going to have your minus 4 from the original. So your final answer here is going to be x squared plus 14x plus 45. And again, you have a polynomial, so that domain is going to be all real numbers. Okay, so carrying on with our next problem, again, f of g of x. So again, let's remind ourselves that we are substituting function g into function f. And f is 3 minus x. So I'm going to say 3 minus, but in place of x, I'm going to put function g, which is x over x plus 1. Now, to work this out, remember we'll put 3 over 1, and just like what we did earlier, we'll multiply these denominators together, and that's just going to give me x plus 1. Then we cross multiplied here, and keep in mind you need to multiply to every part of that, so it's going to be 3x plus 3, and then we have minus 1 times x, or minus x. Now let's simplify that down. We're going to have 2x plus 3 over x plus 1. Now this is not a polynomial. This is going to be a rational function. So that means we probably don't have all real numbers. If we look at the domain, that denominator, we need to set that equal to 0, and that's going to give me -1. So our domain is going to be all real numbers except when x is -1. Okay, and just like earlier, if we change the order, that will change what we have. So this time we're going to have g of f of x. So I'm going to be substituting in function f this time. So everywhere I see an x, I need to put 3 minus x. So g, and I'm going to write the function g because this one can be confusing. Function g is x over x plus 1. So what's going to happen here, where I see these x's, that's going to become the function f, and the function f, let's remind ourselves, that's 3 minus x. So when we start looking at our composite, which is g of f of x, then that's going to be, in place of x, I'm going to put 3 minus x over, again in place of x, 3 minus x, and then plus 1. And now we can simplify that denominator. We're going to have, it looks like 4 minus x. And now we can talk about our domain. The domain here is going to be all reals except, and again, what's going to make that bottom 0? It looks like when x is 4. Continuing with these composite functions, notice this next one is f of g of x. And so we are plugging in g of x into f of x. And so let's look at what that's going to end up being here. So when we go substitute that in, we're going to have 9 minus, and we have 2x cubed, but in place of x, I'm putting function g, so that's going to be 4x minus 1. And that's going to be all cubed. And now we need to multiply that out. So down here at the bottom, we have 4x minus 1 times 4x minus 1 times 4x minus 1. I'm going to bring down that first 4x minus 1, and then I'm going to do our FOIL here. So that's going to be 16x squared minus 8x, and then plus 1. And then we go through and we need to multiply that all out again. Goodness, so we're going to have 64x cubed minus 32x squared plus 4x. And then coming back with our -1, we have negative 16x squared plus 8x minus 1. All right, so let's put this back up here. So we're going to have 9 minus 2 times, we've got 64x cubed. We have negative 32x and negative 16x, so that's negative 48x squared. and then we have plus 12x, and then minus 1. Okay, and then we have 9, and we're going to distribute that negative 2 through everything. So I have negative 128x cubed. We have positive 96x squared, negative 24x, and then positive 2. And we're almost done with this. It looks like we can combine our 9 and our 2. So our composition function is negative 128x cubed plus 96x squared minus 24x plus 11. And our domain, this is a polynomial, so it is all real numbers. Okay, so now for part B. Very similar, however, the order is changed, so maybe that'll make the problem a little easier. We've got g of f at x, and so substituting in here, that's going to be 4 times 9 minus 2x cubed, and then that's going to be plus 1, and so we're going to have 36 minus 8x cubed, and then we have plus 1. And so we're going to have negative 8x cubed plus 37. And our domain for this one, it is a polynomial, so it is all real numbers. Okay, so for our example 4a, we are going to have f of g at x. So I need to substitute in. And f of x is the square root of x plus 5, but in place of that x, I'm going to put g of x, and g of x is x squared. So this just ends up being the square root of x squared plus 5. And this domain, since there's no way to have a negative under the radical, and I know that because of the x squared, then this is going to be all real numbers. Now let's reverse that order, and again, please remember you are not going to get the same answer. You need to reverse this, and when you do that, keep in mind that g of x was x all squared, and then f of x was the square root of x plus 5. And notice that this would simplify down to be just x plus 5. And this domain would still be all real numbers. Okay, so for our next problem here, we are looking at f of g at x. So f of g of x. And so what we're going to do is substitute in g of x, and that's going to be the cube root of x plus 4. And that's going to be cubed, and then minus 1. And so we're going to have x plus 4 minus 1, so we have x plus 3. And again, the domain here is all real numbers. Now changing out this order, we are going to have the cube root of x cubed minus 1, and then we also have plus 4, and keep in mind that's under this radical here. And so now those cubes will not cancel. Be careful with that. You can combine those, so you're going to have x cubed plus 3, and since you have an odd root here, your domain will be all real numbers. Okay, so for the next part, we will be evaluating, and so we definitely need to remind ourselves of what this should look like. It is f of g at 3, and keep in mind your order of operations would insist that you start with the inside most. So we need to start with finding the value for g at 3. And so looking at that, g at 3 looks like it's going to be 3 plus 1, which is 4. And so now I'm going to replace g at 3 with its actual value of 4. And so now I'm going to solve for f at 4. And f at 4, we would go back over and plug in. That's going to be the absolute value of negative 2 times 4. And so that is going to give me 8. Now looking at part B, do pay attention to the order because it will matter. You've got g of f of negative 5, And again, we need to start with the innermost, so I need to find f at -5. And looking at this, it looks like f at -5 is going to give us +10. And so we do replace that value. And so now we need to find g at 10. And substituting that in, looks like we're going to get 11. Okay, for our next problem, again, order does matter. We're looking at f of g at 9. So we need to start with g at 9. And that looks like that's going to be the square root of 5. So now we're going to find f at the square root of 5. And that's going to give us the square root of 5 squared plus 5 times the square root of 5. And so we're going to have 5 plus 5 root 5. And you cannot put that together. That's as far as you can go with those. Okay, now reversing the order, again, that's going to change a little bit. So for this one, remember this is g at f at 7. And so finding f at 7, you're going to have 7 squared. So 49 plus 35. And so that looks like that's going to give us 84. And now we need to find g at 84. And that's going to give us the square root of 80. And the square root of 80 should break down 16 times 5. So that's going to be 4 root 5. Alright, so for our next part, we've got f of g at x is h of x, and it wants us to decompose this function. So I'm going to rewrite this because it would make it a little bit easier, I think, to see that that means f of g at x. And so the inside part here, that is your g at x. And then this outer part, that is going to be your f at x. So it looks like our two functions here, g of x was 1 minus 2x, and then f at x was x cubed. Because it can't just be the parentheses there cubed, it was your x was there. Okay, so for number 9, same idea again, the innermost here, taking g of x, that's going to be this inside portion, so that's going to be x squared plus 1, and then, not h at x, sorry, f at x is going to be the outer part, which is that cube root, so it would have been the cube root of x. Alright, so for our next one, number 10, that one's kind of a strange looking one. However, the substitution part is going to be right inside there. That's going to be your g of x is going to be that x plus 7. And then your f at x is going to be the 4 over x and then minus 1 out there. Right? And then for number 11, inside part of the function, that is going to be x plus 5, and then the outer, that's going to be that -1/2, then the function plus 3.